Welcome back. So, in part one, we dove into the theory, why mixing statistics and machine learning is such a game changer for predicting customer value. Well, we are done with the why. Now we're jumping straight into the how. This is Notebook 1, and this is where the code really meets the road. Okay, first things first. We got to set the stage. Before we can do any of the fun analysis, we need to get our environment prepped and, of course, load up the raw data. So here's our game plan for this walkthrough. First, we're going to get that FinTech dataset ingested. Second, we're going to build our pipeline to scale right from the get-go. And third, the detective work begins. We'll do an initial exploration to figure out what's really driving customer value. Now, you might be looking at this and thinking, wait, PySpark? For a dataset this small? It's all about designing for scale from day one. And here's how we're going to do it. It's a super clean 3-step workflow. We start by loading the CSV into Pandas. Then, boom, we immediately convert it into a Spark data frame. That's for the heavy lifting. And finally, we create what's called a temporary view, which is a clever trick that lets us run SQL queries right on top of our data. So what are we actually working with here? Our data set has about 7,000 customers. It's a manageable size, sure, but it's the perfect playground to build and test our scalable approach. And a quick peek at the schema tells us we're in fantastic shape. The data types are exactly what we need. Long integers for things like age and transaction counts, and doubles for all the money values. And there it is, our target variable, LTV, ready and waiting for us. All right, the data is loaded and ready. Now the fun begins. Let's start our exploration by hunting for the most obvious clues, the really clear predictors of customer value. Let's find that strong signal. Okay, think of this heat map as our treasure map. It shows us how every single number in our data set relates to every other number. The rule is simple. The darker the red, the stronger the connection. And to figure out what predicts LTV, all we have to do is look at that bottom row. And wow, the story it tells is crystal clear. Total transactions and average transaction value both have really strong positive correlations, right around 0.65. But then you get to total spent, and it's a perfect 1.00. That's as strong as it gets. Now, hold on. In a real-world project, seeing a perfect 1.0 correlation would set off all kinds of alarm bells. It's a huge red flag for something called data leakage, which basically means the answer to the test is already in the data. But since this is a synthetic data set, it's not a mistake. It just tells us how LTV was created. And for what we're doing, that's totally fine. We want to see if our model can leverage these super obvious signals. So we know that what customers do, how much they spend, how often they buy, is a huge predictor. But what about who they are? Let's shift gears now and investigate the features that maybe surprisingly don't give us much of a signal at all. I mean, this is the classic marketing assumption, isn't it? That a customer with a high income is naturally going to be more valuable. But is that actually true in our data? Let's find out. And these box plots are going to give us a definitive answer. They show the whole range of LTV for different groups of customers. The key thing you want to watch is that green line in the middle of each box. That's the median. It represents the value of a typical customer in that group. And the results here are, well, they're absolutely fascinating and honestly completely counterintuitive. Just look at income level. The median LTV, that green line, is practically identical for high, low, and middle income groups. Same story for location. It doesn't seem to matter at all if a customer is from a rural or urban area. So this table pretty much sums up our investigation so far. And it's a story of stark contrast. Transactional data, what people do, is an incredibly strong predictor, but demographic data, who people are, has almost zero predictive power. This one discovery is the entire justification for building our hybrid model. So this brings us to our final section. Let's pull all of these findings together and map out where we're going next. So what's the big takeaway from all this exploration? It's simple, but it's powerful. We've been looking in the wrong place. The real signal isn't in static labels like high income or urban. The real predictive magic is hidden in the story of their transactions over time. Now, to tap into that story, we need to go way beyond simple counts and averages. We need to engineer a new, smarter feature that actually captures the pulse of a customer's engagement. And that feature is called P-Alive. It's the probability that a customer hasn't quietly left and is still an active part of the business. And that is exactly where we're headed. In the next explainer, we're going to jump into Notebook 2. We'll use this super powerful BTYD, or Buy Till You Die library, to calculate this crucial PLI feature for every single one of our customers. It's going to be awesome.